What if I told you that NASA just found something moving through our solar system that breaks every rule we know about comets? An object so strange that when the data came back, 3 separate teams of scientists refused to believe what they were seeing. On September 1st, 2019, an automated telescope in Hawaii detected a faint dot moving against the stars. Within hours, scientists realized this wasn't just another comet. The way it moved, the way it looked, the way it behaved, nothing added up. They gave it a name. 3-I-A-T-L-A-S. The I stands for Interstellar, and over the next few months, this object would force astronomers to question everything they thought they knew about what exists beyond our solar system. Here's the thing about comets. We've been studying them for hundreds of years. We know how they're supposed to act. When they get close to the sun, they heat up, ice turns to gas, and you get that classic tail streaming behind them. It's predictable. It's science, we understand. But 3I, Atlas didn't care about any of that. When astronomers first started tracking it, they noticed something immediately wrong. This comet was brightening way faster than it should. We're not talking a little bit faster. We're talking about becoming 10 times brighter in just 2 weeks. For context, a normal comet might take months to brighten that much. Dr. Michelle Bannister from the University of Canterbury was one of the first to study it. She told her team to double-check their calculations because the numbers didn't make sense. They checked, then they checked again. The readings were correct. This thing was actually doing what their instruments said it was. But it gets stranger. Most comets have a greenish glow around them. This happens because of something called diatomic carbon, basically. Carbon molecules breaking apart in sunlight. Every comet we've ever studied in detail has this green color. It's like a signature. It tells us what comets are made of. But 3IA Atlas had no green glow. None. Zero. Imagine you're a doctor, and every human patient you've ever seen has red blood. Then one day, someone walks in, and their blood is blue. That's basically what astronomers were dealing with. This wasn't just unusual, it was impossible, according to everything we knew. The team at the European Southern Observatory in Chile pointed some of the most powerful telescopes on Earth at 3IA TLAs. The spectroscopy data came back, and multiple scientists literally stood up from their desks. The comet was releasing cyanogen gas. Lots of it. Now, the thing about cyanogen is, it breaks down really quickly in sunlight. 4-3I. Atlas, to be producing this much meant its composition was completely different from anything in our solar system. Think about that. This object formed somewhere else, around a different star, in a different stellar neighborhood. It grew up in completely different conditions than anything we've ever studied. And now, it was flying through our cosmic backyard. The discovery of 3IA TLAs came just 2 years after another interstellar visitor shocked the scientific world. And if you think 3I Atlas is weird, Oumuamua was on another level. It looked like a giant space cucumber, tumbling through space in a chaotic rotation. And here's the kicker. It was accelerating away from the sun in a way that gravity alone could unexplain. Some scientists even suggested it might be artificial. That's how strange it was. But Oumuamua disappeared before we could study it properly. It moved too fast, and our telescopes lost track of it. So when 3I Atlas showed up, astronomers around the world went into overdrive. This was their second chance. They weren't going to let this opportunity slip away. Telescopes in Hawaii, Chile, Spain, and Arizona all locked onto the comet. Amateur astronomers joined in too. Everyone wanted to be part of this. The data started pouring in, and it just kept getting weirder. The comet's nucleus, the solid centipede, was incredibly small, maybe 300 meters across. But the coma, the cloud of gas and dust around it, was absolutely massive, stretching for over 100,000 kilometers. Dr. Alan Fitzsimmons, from Queen's University Belfast, led a team studying the comet's composition. His analysis revealed that 3I Atlas was losing mass at a ridiculous rate. It was literally falling apart as it moved through space. Most comets are tough. They survive multiple trips around the sun. But 3IA Atlas was fragile. Extremely fragile. It was like comparing a rock to a snowball. This told scientists something important. 3IA is probably formed in the outer regions of its home star system, way out where it's incredibly cold. Colder than anything in our own solar system. It never got close to heat, never hardened up. Then something happened. Maybe its star died, or a planet's gravity kicked it out. Whatever the reason, 3IA was ejected from its home and started wandering through interstellar space. And here's where your mind should be blown. Scientists calculated its trajectory backward. The comet had been traveling through the empty void of space for millions, maybe tens of millions of years, just drifting in the darkness between stars, exposed to cosmic radiation and intense cold. Then, purely by chance, our solar system got in its way. The odds of this happening are so small, they're almost impossible to calculate. Space is unimaginably huge. If you shrank the sun to the size of a basketball, the nearest star would be 15,000 kilometers away. And somehow, this tiny, frozen object threaded that cosmic needle. In early December 2019, something unexpected happened. Astronomers watching 3I Atlas noticed it was changing fast. It was breaking up. Images from the Hubble Space Telescope showed the nucleus splitting into multiple pieces. The comet wasn't just losing material anymore. It was actively disintegrating in real time. This was both exciting and terrifying for scientists. Exciting because they were witnessing something unprecedented, but terrifying because their window to study it was closing rapidly. Dr. Bryce Boland from Caltech scrambled to get more telescope time. Every observatory with a view redirected their instruments in a race against time. The fragmentation revealed even more mysteries. As the comet broke apart, scientists could see inside it, analyzing material that had been locked away since the comet first formed. The spectroscopic analysis of these newly exposed areas showed something that made NASA scientists call emergency meetings. The interior composition was different from the exterior. Think about what that means. The comet formed in layers, like an onion. This suggested its home star system went through dramatic changes while it was forming. Maybe the star itself was unstable, or giant planets were moving around, changing the environment. Whatever happened, it was recorded in the layers of this comet. 3-1. Atlas was carrying a messages story written in ice and rock about a solar system we'll never see. But here's what really scared some NASA scientists. The rate of fragmentation accelerated. The comet shattered into dozens, then hundreds of fragments. It was like watching a slow-motion explosion. And NASA realized something disturbing. If an interstellar comet could break apart this easily, what did that mean for planetary defense? NASA tracks objects that might hit Earth and has plans to deflect them. But those plans assume we're dealing with objects from our own solar system. What if an interstellar comet was on a collision course and we tried to deflect it, but it just broke apart? You wouldn't have one problem anymore. You'd have hundreds of problems, all still heading for Earth, but now impossible to track accurately. The trajectory of 3I Atlas brought it relatively close to Earth's orbit. Not dangerous this time, but it proved interstellar objects could absolutely cross our path. Before 2017, we'd never detected an interstellar object. Then we found Almo. 2 years later, 3I. Either we got incredibly lucky, or these objects are way more common than anyone thought. And if they are, that changes everything. Dr. Darrell Seligman from the University of Chicago published a paper estimating there could be thousands of interstellar objects passing through our solar system right now. We just can't see them. That means every single day, pieces of other star systems are flying past Earth, fragments of alien worlds, carrying information about the galaxy that we're missing. As 3IATLAs continue to disintegrate, scientists rush to gather every last bit of data. And in doing so, they opened up a whole new field of astronomy, proving that our solar system is not an isolated island, but part of a vast, interconnected galactic neighborhood. Thanks for watching. If you found this as mind-blowing as we did, do you want to forget to hit that like button and subscribe for more deep dives into the mysteries of our universe? We'll see you in the next one. Here's something wild. One team discovered that fragments of Comet 3I Atlas were outgassing ASIM. Imagine gas jets firing from specific spots, not evenly across the surface. These acted like tiny, natural rocket engines, pushing the fragments around in completely unpredictable ways. This made tracking the pieces almost impossible. All our computer models, the ones that work perfectly for regular comets, totally failed. 3-1 Atlas was playing by its own rules. Dr. Matthew Knight, from the Naval Research Laboratory, put it perfectly to a congressional committee. He said, "We're not just observing a comet. We're watching something that fundamentally doesn't belong here, try to survive in our environment. It's like dropping a deep-sea creature into a swimming pool and watching what happens." And that analogy was frighteningly accurate. Think about it. 3-1 Atlas had spent millions of years in the cold, silent void between stars. Our solar system, Bicomparison, is a chaotic storm. There's the sun's radiation, the solar wind blasting particles at hundreds of kilometers per second, magnetic fields, and gravity pulling from all directions. For an interstellar traveler, entering our solar system is like jumping into a hurricane, and 3I Atlas was literally falling apart because of it. But even as it disintegrated, the comet was spilling its secrets. Analysis of the gas it was releasing showed traces of complex organic molecules. We're talking chains of carbon, hydrogen, oxygen, and nitrogen. The very building blocks of life. Now, hold on. These weren't living organisms, just simple molecules. But they were complex enough to make astrobiologists sit up and take notice. One of the biggest questions in science is whether the ingredients for life are common in the universe. Is Earth special, or does every planet get the same starter kit? Finding these molecules on 3I Atlas suggests they form naturally in other solar systems. They're not unique to us. They're probably all over the galaxy. Dr. Jennifer Bergner from UC Berkeley said it best. Every time an interstellar comet visits a young solar system, it's potentially delivering organic chemistry to brand new planets. These objects could be spreading the seeds of life throughout the galaxy. The implications are staggering. Life on Earth might have started with ingredients delivered by an ancient comet from another star. And right now, comets from our own solar system might be carrying Earth's chemistry out to other stars. It's like a galactic postal service for chemistry. And we're all exchanging packages without even knowing it. By late December 2019, 3I had fragmented so completely that it essentially dissolved into a faint cloud of dust and gas. But scientists weren't done. Researchers in Germany built detailed computer simulations to understand not just what the comet did, but asterisk. Why? Asterisk, the simulations revealed something incredible. The comet's trajectory showed it had never gotten close to asterisk. Any asterisk star before entering our solar system, not once in its entire multi-million-year journey. This means 3I Atlas was a pristine sample. It hadn't been cooked or altered by stellar radiation. It was a time capsule from the moment it first formed. This made it unbelievably valuable. It was a direct sample of the raw materials from another solar system. When scientists compared it to our own comets, they found big differences. The ratio of different isotopes in 3I Atlas didn't match anything from our solar system. Isotopes tell you about the conditions where an object formed. The ratios in 3I Atlas indicated it came from a system with a different balance of elements than our sun. Maybe its home star was older or younger. The point is, it was different. This confirmed what scientists suspected. Every star system is unique. Dr. Olivier Hanot from the European Southern Observatory said, "Studying 3I is like being a detective who finds evidence from a crime scene in another country. You can learn a lot about what happened, but you'll never be able to visit the place where it occurred. That's the frustrating beauty of it. We can study these visitors, but we'll never see their homes." The star 3I came from could be shining in our sky right now, or it could have died billions of years ago. It's a postcard from a location that might not even exist anymore. The whole saga of 3I completely changed how NASA thinks about interstellar objects. Before, they were just theory. Now we know they're real. They pass through, and we need to be ready. NASA is now funding new sky surveys specifically to spot these visitors earlier, giving us more time to study them. There's even serious talk about launching a probe to intercept the next asterisk 1. The European Space Agency is designing a mission called Comet Interceptor, set to launch in 2029. It will literally sit in space, waiting, ready to chase down the next interstellar target. But there's a catch. These objects are fast. Really fast. 318 TLAs was moving at over 70,000 miles per hour. Catching up to that is a massive engineering challenge. You might get there just to find it is already disintegrated. So, some scientists propose a different idea. Instead of chasing them, let's find the ones that got trapped. If a visitor enters at just the right angle and speed, our sun's gravity can capture it. These would be permanent residents, making them much easier to study. Models suggest there could be thousands of them hiding in our solar system right now. The new Vera C. Rubin Observatory in Chile will soon begin scanning the entire sky every few nights. And finding these captured objects is a top priority. One thing that truly bothered scientists was how fragile 3I Atlas was. This raises a chilling question. How many interstellar visitors pass through completely undetected because they fall apart before we even notice them? We only spotted 3 IA TLAs because it flared up. What if most are more fragile, breaking up while they're still too far away and dark to see? Research from the Space Telescope Science Institute suggests that for every interstellar object we detect, there could be 100 more we miss. The ones we see are the exceptions. This means our understanding of how many of these things are out there is probably way off. The galaxy could be teeming with them. And if that's true, it changes everything. Solar systems aren't isolated islands. They are constantly exchanging material. Our solar system contains material from other stars too. IA-TLA has proved that, and that means fragments from our own system, maybe even from a young Earth, are likely orbiting other stars right now. The solar system isn't a closed box. It's an open system, connected to the rest of the galaxy. In just a few short months, 3 IA-TLAs rewrote the book on interstellar visitors. It showed us they can be radically different from our local comet. It proved that the building blocks of life are likely common throughout the galaxy. And it scared scientists. Not because it was a threat, but because it revealed just how much we don't know. Every answer it gave us led to 10 new questions. Where did it come from? How many more are out there? We may never have all the answers, but we will keep watching. We'll build better telescopes, and when the next interstellar messenger arrives, we'll be ready, because one thing is certain, there will be a next time. The age of interstellar astronomy has just begun. If you want to explore more cosmic mysteries like this, make sure to hit that subscribe button. Thanks for watching.